Welcome to the Explainer. Today, we are going to break down two of the absolute most fundamental concepts in C++, classes and objects. So how does a language like C++ even begin to model the real world? Well, it all starts with this incredibly powerful idea that lets us create digital blueprints for, well, pretty much anything we can imagine. All right, here's what we've got on tap. We'll kick things off with that core blueprint and building idea. Then we'll see where this stuff actually gets stored in memory. After that, we'll get into a super important concept called encapsulation. Think of it as keeping secrets. We'll cover how to access all the parts, and then we'll get our hands dirty and actually code a time class together. All right, let's jump right in. This is the big idea, the foundation of it all. A class is the blueprint, and an object, that's the actual thing you build from it. So imagine a class is like a super detailed architectural plan for a house, right? It lays out everything. It defines all the properties, stuff like the number of rooms. We call those member variables. And it also defines all the things it can do, like opening a door. We call those member functions. But here's the key. It's not a house. It's just the design on paper. Now, an object, that's the actual house, the one you built from the blueprint. It's a real, tangible thing that exists. It takes up space in memory, and it has its own unique details. Like this house is painted red, and that one has a specific address. So if there's one thing to get from this, it's this. The class is just the abstract design. It's an idea. It doesn't use up any memory for data. But the objects, those are the real, concrete things you make. And the second you create one, boom! Memory gets set aside to hold its specific, unique data. And here's what that looks like in actual code. See that class item? That's our blueprint. We only define it once. Then, over in our main function, we actually build two different things from it, T1 and T2. Each one is its own separate item out in the world, totally ready to have its own unique properties set. Okay, so when we create these objects, where do they, go? Where do they live in the computer's memory? It's actually a little more clever than just making a full copy of the entire blueprint every single time. And this is what I find so cool about how C++ handles this. It's super efficient. The how-to instructions, the member functions, they're only stored in memory one time. All the objects of that class just share them. But the data, the member variables, that's different. Each and every object gets its own private, dedicated block of memory for its data. And that makes perfect sense, right? Because every object needs to hold its own unique values. This idea of each object having its own private data leads us right into one of the most powerful features in all of object-oriented programming. And that's this idea of keeping secrets. Let's talk about how a class protects its own data. So this concept has a name. It's called encapsulation. And the name is perfect. Think about a medicine capsule. It keeps all the different ingredients safely bundled together inside. A class does the exact same thing. It bundles its data, its variables, and the functions that are allowed to operate on that data all into one single, self-contained unit. And why do this? Well, this bundling gives us control. Look at this diagram here. We can create these layers of access. We can stick our most sensitive, important data right in the middle, in that private inner circle, totally insulating it from the rest of the program. This is a game changer because it stops other parts of the code from accidentally messing with it, which makes our programs way more stable and predictable. And we manage these layers with three simple keywords. Now, by default, C++ plays it safe. Everything is private, total lockdown. If you want the outside world to be able to interact with something, you have to explicitly mark it as public. That becomes your public interface. And then there's protected. Think of it as a middle ground. It's kind of like private, but it lets future child classes, through something called inheritance, get access. Okay, so we have these rules, these access levels in place. How do we actually, use the members of an object? Well, it all depends on where you are. If you're outside the object, say in your main function, you can only touch the public stuff, and you do that using the dot operator. But if you're inside the class, a member function can access any other member of its own class, no problem. Private, public, whatever. And you can even have classes talking to each other by having one class create an object of another class to use its public features. All right, ready for a more advanced trick? C++ actually lets you define an entire class inside of a function. Yeah, for real. This is called a local class, and it's perfect for those super specific one-off tasks that are only needed inside that one single function. But this power comes with some pretty strict guardrails to keep things from getting messy. For instance, you can't have any static data members, and all the member functions have to be defined right there inside the class definition. Most importantly, the function that contains the class can't just peek into its private members. These rules are there for a reason. They make sure these local classes stay as simple, self-contained little helpers.
Okay, that's enough theory for now. Let's put all this into practice. We're going to build a time class from the ground up and use it to solve a couple of real challenges.
So, challenge number 1, multiplication. Our goal is to design our time blueprint so that we can take a time object, let's say 2 hours and 20 minutes, and just multiply it by a regular number, like 3. The real puzzle here, of course, is making sure our code is smart enough to handle carrying over the minutes into hours correctly.
All right, next up, we're going to give our class a new power, addition. We need to build a function that can take 2 completely separate time objects and add them together. And just like before, the tricky part is handling that 60-minute clock logic, making sure that when minutes go over 59, we carry the extra into the hours column.
And check it out. Here's our code in action. On the left, it totally nailed it. 2 hours and 20 minutes times 3 is exactly 7 hours. And on the right, adding 2:45 and 3:30, it correctly carries the hour and gives us 6:15. You see what we did? By bundling the data and the logic together inside our class, we've built this awesome, reliable, and reusable tool. Our blueprint works perfectly. And that right there is the real power of all this. We didn't just solve a couple of math problems. No, we created a brand new type of thing in our program, a time object that actually understands its own rules. You can take this exact same blueprinting idea and apply it to literally anything: a character in a video game, a bank account, a song in a playlist. You get to define what it is and what it does. So it really just leaves one question, right? Now that you know how to build a blueprint, what are you going to create?